This video is about gravitational potential difference. Let's begin by recalling the formula for gravitational potential at a point. Here, g is the gravitational constant, m is the mass of the uniform sphere or point mass, due to which the gravitational field arises, and r is the distance between the center of the sphere and the given point. We'll now take a uniform sphere, for example a planet, and 2 points, x and y, that lie at different distances from the center of the sphere. We'll denote the gravitational potential at x as Vx and at y as Vy. Then we'll also sketch a graph that shows how gravitational potential varies with distance from the center of the planet. Since Vg, gravitational potential, is inversely proportional to r, so the distance from the center of the planet, we can draw the graph like this. It is likely that you will come across this graph on IB physics exams. Since the gravitational potential is negative, the graph is below the horizontal axis, and as r approaches infinity, Vg approaches 0. As you can see, I've added the sphere at the bottom of the graph in order to show where the center and the surface of the planet lie. It is interesting to note here that, as you can see on the graph, gravitational potential at any point inside a solid sphere is the same as at the surface of the sphere. Here we do not need to go into the details of why this is so. Next, let's plot x and y on the graph to help us better visualize the situation, and then take an object of mass lowercase m and move it from point x to point y. Now, if we would simply release this object at point x, it would accelerate towards the sphere due to the gravitational force that the sphere exerts on it. Therefore, when moving the object from x to y, work must be done on the object. We'll denote this work done as W. As the gravitational potential at y is Vy and the gravitational potential at x is Vx, we can express the gravitational potential difference between x and y, so delta Vg, as Vy minus Vx. We also learned earlier that gravitational potential at a point is defined as the work done per unit mass when bringing a small test mass from infinity to the point. So if we take our object in this question to be the test mass, we can express Vy as Wy over m and Vx as Wx over m. Of course, Wy here is the work done when bringing the object from infinity to y, and Wx is the work done when bringing the object from infinity to x. The key here is that Wy minus Wx gives us the work done when moving the object from x to y, so simplifying, we get W over m. Based on this, we can define gravitational potential difference between 2 points in a gravitational field as the work done per unit mass when moving an object between the points. Here is the related formula that is provided in your data booklet, along with the variables. With this, we have completed our video about gravitational potential difference.